Welcome, Vimal Bhatia, sir. Sir, welcome to this FDP. I hope you have joined.
Hello. Yes. Good afternoon. Yes. I'm
Good
here.
afternoon.
Yeah. Thank you very much.
Okay. Sir, on behalf of Editor Bhopal, Director, Faculty, and participants, I extend a very hearty welcome to you in this FDP. This is 5 days ATAL FDP, incubation, entrepreneurship, and startup. Sir, this is the third day of the program. We have got around 100 participants. Few more would be joining shortly. Friends, I would like to introduce Vimal Bhatia Saab to you. Vimal Bhatia Saab is currently working as a professor with the Indian Institute of Technology, Indore, India, and is an adjunct faculty at IIT Delhi and Triple IIT Delhi, India. He received PhD degree from Institute of Digital Communications with the University of Edinburgh, UK in 2005. During PhD, he also received the IEE Fellowship for Collaborative Research at the Department of Systems and Computer Engineering, Carleton University, Canada, and is Young Faculty Researcher Fellow from MEITY, Government of India. He is also a recipient of Professor SVC Aya Memorial Award 2019. He has worked with various IT companies for over 11 years, both in India and the UK. He is also placement coordinator for external projects with funding of over USD 17 million from METI, DST, UKERI, MOE, ACA, IUSTF, and KPMG. He has more than 300 peer-reviewed publications and has filed 13 patents with 4 granted. He has supervised 15 defended/submitted PhD thesis. His research interests are in the broader areas of communication, non-Gaussian, non-parametric signal processing, machine deep learning, with applications to communications and photonics. He is a reviewer of IEEE, Elsevier, Wiley, Springer, and IET. He is currently senior member of IEEE, fellow IETE, and certified Scrum Master. He was also the general co-chair of IEEE Enters 2018 and general vice chair of IEEE Enters 2017. He has served as founder head of Center of Innovation and Entrepreneurship, Associate Dean R&D, and Dean Academic Affairs. He has delivered many talks, tutorials, and conducted faculty development programs for the World Bank, NPIU, TechCube 3, and invited talks at WWRF 46 Paris. He is currently associate editor of IETE Technical Review, Frontiers in Communication and Networks, Frontiers in Signal Processing, and IEEE Wireless Communication Letters. So this was a brief introduction. Sir has been very keenly associated with startups, innovation since long. Sir has contributed to many of our other programs also with NITR Bhopal. Sir, I extend a very heartily welcome once again. And now the floor is yours. Please, sir, go ahead.
Thank you. Thank you very much indeed. Thank you, Dubey. And we have been in touch for a while now, and always a pleasure to meet you and talk to you. So thank you very much, and I hope the FDP is going great. And so congratulate your team to get this FDP to be done here at NITR, and um, it's a it takes a lot of planning and thought into designing this type of courses, and coordination with a lot of speakers. So thank you very much, and I congratulate your team for this, and all the best also for the future as well. Now, what I'll try to do is first give you a brief overview of what we are working on, in our research group. So briefly, yeah, Dubiji also mentioned. So I'll go briefly onto that, and then we'll look at entrepreneurship, which is a topic which I is close to me, and
Sir,
I've been
sir,
working.
Nishit Dubey this side.
Yes, sir.
Uh, some disturbance is coming. I do not know. Audio disturbance is coming. It is from which end? Uh, now it is not there.
Okay, okay. Is there
But
a maybe a network problem?
no, sir. It seems. Uh, can you just cross check your connections? Plug in once again, sir. Are they loose?
Yeah. No, this is okay. Let me. Okay, if I maybe show this power one. Okay, so now how it is?
Now it's very good. Excellent, sir. Okay, it's okay. Yeah.
Okay, okay. So I think
Good.
there's some earthing problem or something is there. Okay. Okay, so we'll continue this way. Right. So yeah. So what I'll do, I'll give a short overview of our research area. So you might be able to maybe relate to that in certain thing, or maybe in future you want to get in touch with us on any of these things. So I'll just give you a small short overview on that. After that, we'll look at um, about what is entrepreneurship, what are different things, and what are different schemes from government that are there that you can always explore and join. And some of those, one of those schemes actually we had at Indore as well, and we were able to get a few of those student starters from that small seed funding that we got from DST. And then we'll how much time permits, we'll look at the some of the technological areas that you can apply in your work. So I believe like many of you from different science, technology, commerce, pharmacy, different backgrounds, you are here. So there's some common things that I'll try to cover in. So we'll see if we get time to go a little bit into the technology aspect as well. Um, so let me first share this. And so yeah, this program that that Mr. Dubey was mentioning, it's actually very interesting. Um and yeah, I'll also encourage you to see that one, and so you'll see what kind of questions and what are things that you need to look at when you're trying to pitch for your product, or pitch for some external funding, and things that needs to be taken care of when you are going to start your own enterprise. So let me first go a little bit into the technical aspect that we do, and then we come back and look at the uh, entrepreneurship aspect. So as the way you mentioned, I'm Professor Vimal Bhatia. I'm working as a professor in electrical engineering and Center for Advanced Electronics at IIT Indore. I'm also adjunct faculty with Bharati School of Telecommunication Technology Management at IIT Delhi and Department of ECE at IIIT Delhi. And recently, I'm visiting faculty of Information and Management at University of Hardik Karlov in Czech Republic. Um, so I'm editor for IEEE Wireless Com Letter, editor for IT Technical Review, SU writer for Frontiers in Communication Networks and in Signal Processing. And some of the work we have been doing is with, well, most of the work is actually with my student and my team here and other collaborators across the globe. And our work has primarily been funded by these agencies, MIT for so Ministry of Electronics and IT, and DST, Department of Science Technology, SERP, Ministry of Education, aka Finland, now recently with the TFK Finland as well, UK IERI, and IUSSTF. So UK IERI is for the UK collaboration, and IUSSTF for the US one, and the European and the other funding agencies. So we work on different areas. In so mostly as in mentioned, so I basically work in the physical layer uh, area, so that encompasses signal processing, communication, machine learning, deep learning things. We look at different algorithms for communications for 5G, and now our focus is more on 6G and beyond networks. Some of the applications on biological aspect we have looked at, some algorithms for detecting if this, let's say, the seed is viable or not. So farmers can check before sowing the seed if it is viable or not. Um, then looking at some of the early disease causing in different plants, if we can use again some machine learning type of techniques to get some indication of this. So that's interdisciplinary work we do along with IT, DAVV, and Soybean Research Center at Indore. Then others, these are okay, technological words. So FD, MIMO, if you're from ECE background or communication, you would know. But otherwise too, when you're purchasing a mobile phone or a Wi-Fi system, you look for if MIMO is there or not, or which standard of IEEE 802, which series it is using, 802.11, ABG. So that area that I work in. Another area that is upcoming is on visible light communication system, where we are looking at some algorithm development. But this is an area that is going to come up hopefully, and slowly we are seeing some of the products being deployed in certain places. Uh, so this is the idea. The basic idea is that we can try to use, or we can use the lighting infrastructure. So we can use our LED bulbs, LED tube lights for communication purposes. And this is not this is not blue sky or some a dream, but it is very much there. There are devices now available which can be used for both illumination as well as communication. Then again, we are working on optical and quantum networks. This is another thing that we will hear more in this decade about quantum computing, quantum communication, quantum other things that come in. But our focus on quantum communication, basically trying to secure our networks. As we know, with coming of the quantum networks, computing, uh, our current encryption algorithms could be deciphered within in real time. So we need to look at some alternative ways. So quantum key distribution, that's a solution. But again, this early days. But yeah, some places it is already done. In India also, we have a few startups which started working on it. There's one by um, in IIT Madras. This came up with one of the faculty members there, and some other team members. They got together. They started this startup. Now it's a company which is supplying equipments to defense and other um, uh, people. It's called QNU Labs. If you look the history of QNU Labs, you'll find that it started basically from an education institute. It is still linked to IIT Madras, but yeah, now it's a bigger name. It's one of the first, or maybe I think the only company in India which is providing these equipments for quantum communication, quantum networks. Um, then we have and this Li-Fi as well, the visible light communication. If you search for Li-Fi, Lifi, so similar to Wi-Fi, we have Li-Fi. Um, so light fidelity, it is called. It's basically a visible light communication system. They have developed different dongles. You can connect your laptop with a dongle, and you have this lighting uh, in- at the top. It can do communication, so just like your Wi-Fi systems, but it is green. As low energy it takes. It is RF free, so you can use it in mines, in petroleum, in hospitals, in airplanes. You can use them. It is being deployed in. So Philips has been deploying this in one of the um, Carrefour is like in France it is something. It's like a or big bazaars. So it's a big uh, uh, shopping area where you can get groceries and things. So like D-marts and all. So there they have deployed this system. So using your own handset. So handsets, anyways, they have a front camera in the front, and there's a display, so it can detect. So you can download their app and use visible light communication within their stores for navigation, for getting you close to a product that you are interested in. You can make a shopping list and it'll take you there, because it is visible light is also very good in localization. Right. Uh, if you look at GPS, so many times in your home or some places, the GPS signal, indoor locations, the GPS signal gets lost, and again the resolution is not that good. We can use cellular networks, but again in indoor places sometimes cellular network is also not that good. So this is one place, and with visible light we get actually very good uh, 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 precision or localization. So up to in theory it should be in millimeter or even less than that. So it can actually guide you to where the product lies or something. So this also Pure Li-Fi, the company that is the largest one, uh, started off as a spin-off from University of Edinburgh by Professor Harold from the same research group in IT Com. He started his company, and it is the largest supplier to places. It has been running for quite a while now. Started as a startup. Now it is growing growing bigger. So there is you see a lot of scope for this. They take time in some of the areas, but in others it could be faster. And in fact, I think this year has been a very good year for a lot of startups that became unicorn, even becoming within a year or 2 years, they are becoming that. So it is happening a very vibrant, ecosystem we have at the moment. A lot of young population is there. So and if you get encouraged by listening to these talks, then you can think of delving into it as well. And we do provide solutions for industry and defense. So some we are working in the past, some we are working now. Then we have active collaborations with researchers from across the world. Then externally funded, I've already mentioned. So currently we have this project on quantum with the US recently started, and one with the UK is coming to an end, and then with Finland one is finishing, other one is just going to start. It has already started, yeah, recently. Uh, our publications, so we have quite a few more than 300 publications, and in total peer-reviewed publications. Then book chapters, and recently got 4 patents. Now this is an area which takes time. So if you're developing a technology, if you want to do it as soon as possible, because the process is long in India. Um, it has improved in a few last couple of years, but still it is quite long. And if you are, let's say, linked to an education institute, and if the education institute is uh, filing this patent, then I also realized it actually quite late that there is a provision you can, by paying a small top-up fees, you can expedite the process. So within 2 years, uh, the patent could be in the granted stage as well. At least you get the first response. For some of the early patents we filed, the response came after 5 years, the first response. So it used to take a long time. Now it has come down, but still, I think it is still a bit long. And there are certain things that you currently, and I mean, earlier still you cannot do, but things like if you want to, let's say, do take a patent on an algorithm, or you want to take a patent on you see, let's say you want to take a patent on an algorithm or a software. So software in India, we copyright it. And algorithms also, per se, we cannot patent them. But again, in last few years, there was some legislation that said if it is changing something in the hardware, then yes, it can be patented. Uh, Whereas if in states in the US and other places, you can patent a algorithm as well as software as well. You could do that. So there are certain things which are happening, which is happening for good. So let's hope the process gets even faster. So that is an important thing. If you're an entrepreneur, you have developed a product, so should look at patenting that. Uh, Product, which I'll also cover in the slides on entrepreneurship as well, so I could not get it away. Uh, so this is something I can maybe skip them because they're very technical. But this is a one scenario of a visible light communication system where you can do from the lighting, you're connecting different devices, IoT devices, or your laptops and other things. And our focus, although has been on algorithm development, but this is a basic scenario. I just wanted to give you an idea. This is on the there's a new scheme coming for beyond 5G communication system. That's what we are working on, called NOMA. So hopefully 5 years down the line or 10 years down the line, when you buy a handset, you might see NOMA there. This is something about the optical network that we are looking at. This is the quantum key distribution one that I said, you have to be secure, because once the quantum computers become, nowadays they are expensive. Uh, um, a few $100,000 you need for certain slots. But as in future the computing, the silicon chips, they start to appear, they will become reality in our homes, or even let's say slight medium sized businesses. So that's when the problem starts for our current encoding algorithms. So all the communication that we do, all the banking transactions, are all secured by encoding algorithms. So they all, and the defense thing as well, they all get into a soup because they can be decoded instantaneously in real time. So this is an area which people are now looking at. Another area that we have been working on is this is one of the major areas that we work on, is wireless communication, where we try to improve the connectivity. Now here there are now thoughts that a device can talk to a device as well, um, which we are seeing in a way in type of a machine to machine communication, IoT, or in different industries we are seeing. So if you have an industrial setup where you have a lot of machines, so machines can talk to the machine, and there are ways that machine can talk to another machine without going through this full cycle of a cellular network. So currently, let's say you want to talk to someone who is sitting next to you, or in the next room. You have to make a call. It goes to the the base station, to the central store, and then it gets routed down. But if you, let's say, close to each other, something like a Wi-Fi, that walkie-talkie kind of thing. So you could use your current handsets and talk to the person directly, as we do for Bluetooth. So why not for the other voice calls and other services? Um, then yeah, this our work basically has been focused more practical stuff. So I'll say, okay, theoretically a lot of people has done work, but our focus has been on looking practical rates, because when somebody tells you in 4G you get 100 Mbps, but I've not seen it so far on my 4G, and probably none on the call has seen it either, because there are practical constraints. So we, in one aspect, we have done research. We looked at if there's issues in the uh, power amplifiers that we use in our RF system, in our handsets or in our base stations. So what are the rates we can expect? What are the how many errors we can expect? What are the different rates for different schemes? So that when we give a indication that we know that we can't, we don't say, okay, it's a marketing word. You can say 100 Mbps download speeds for 4G, so everybody jumps onto 4G, but in reality, you will not get it. So what are the realistic rates that you can achieve from the physical layer point of view? Then there are other layers in the full telecom stack, so that we have not looked at, but basically focus has been on the physical layer aspect. Now, I'll move on to the slide deck on entrepreneurship. I'm going to the basics of entrepreneurship. Now, first we'll look at some definitions of who is an entrepreneur. Now, an entrepreneur is someone who provides a service or a product from an idea which creates value to the society and benefits society and the self. The implementation of this is called as entrepreneurship. Right, so even a housemaker making pickles at home and selling it to the nearby departmental store is also an entrepreneur. Right, so they're making things at home and selling it either in the local area or in the local departmental store. And as that program that Adobeji mentioned, there, I think in advertisement I see that there is one such, one or two such cases where they are making pickles, or they're making, I think there's one on momos and stuff. So uh, that is also entrepreneurship, and I think they might have got funding. I'm not sure. I think it will be coming, because we've seen in the advertisement there on the television. Um, So now we how do we differentiate between um, different types of entrepreneurs? Um, this could be a type of a product or a service. So, for example, let's say you are making pickles, so that is a product. Maruti Udyog makes uh, cars, so that's a product. Somebody, let's say, making lights for the car or small, small screws and other things. So, rubber things, tires. So, they are all products. Um, or we can classify into service. So service will be something like let's say Uber. So Uber is a cab service company. They don't own a car, but they are the largest aggregators providers. We look at Amazon. Amazon, okay, they had Kindle, but Amazon as such, generally, it is for e-commerce platform. Flipkart, so Flipkart doesn't have a product, but they have this platform. People can come to a glorified, kirana store where people from wherever can connect to them and purchase items there. Um, an electrician who comes to your home and fixes the electrical thing, plumber. So they are all providing a service. Right, so there's this difference between a product and a service. Then we can also differentiate between profit and not for profit. Uh, Mostly the enterprises are for profit, but there are again different NGOs which work with the local community where the focus is for the development or some cause, some kind of a cause. So we see that they are for tribal and other areas. There are some NGOs working together with them to say sell or bring their products to the larger market. So they're mostly non governmental and non-profit, not even governmental organizations which are not for profit, which are the main focus is for the development of the society or for a certain region, um, or even let's for our cultural heritage or something which is being developed in certain part of the country, and the weavers or other handicraft or craftsmen, they don't have access to the market, so they help them out or get them together to do, so they can become like a not for profit or entrepreneurs. Then the next classification is on the basis of scale of the firm or the company. So could look at let's say as a startup. So let's say one or two people starting it up. Then it could be a larger comes like if let's say there's some single person selling an item on the local market or something, or a single person who is electrician as his own company. So it's a single person. It could be a medium scale. You can have 50 or 100 employees. They're working. There's a lot of MSMEs in the country. Um, so we have actually now a ministry as well looking after this. Um, and then it could be a large company. In India as well, we have seen a lot of big companies. So L&T is a very big, large company. Tata, TCS itself has got more than a lakh employees, and the whole Tata group has got uh, a lot of employees there. Then, so they are classified as large companies. So it could be a startup or 4 or 5 people, let's say, joining together, starting, or a medium scale enterprise. Or a very large company. So entrepreneurship could be classified in the size of the company as well. Now, one example is the example of a Dabbawalas of Mumbai. So they provide a service. They carry dabba from one place to another. They provide a different service provider. They use a unique coding and uninterrupted facility. They've got Six Sigma standards. So 1 in 10 to the power 6 items they get lost. And this has been running and working for many years now, and this was before the smartphones became, or when mobile network became common. So I mean, they are not, like MBA graduates or graduates as well. So these people have been running successful supply chain. So this has now become a benchmark for supply chain management systems. So we have our own homegrown ideas and places which have uh, been featured in different documentaries on BBC, and Prince Charles, when he visited, he still visited them as well. So these are some homegrown, wonders that we have. Um, then there was this company called Coursera, which started in 2012. So now it is one of the largest MOOC platform. Now, looking at the success of this platform, now various government organizations have also jumped onto this. So in India also we got NPTEL and Swayam. They're all MOOC platforms for providing education in different areas. So nowadays you can get courses, engineering, humanities, sciences, medicine, business, nursing, anything that you name it, it is there online. So they were one of the first ones. They again started with collecting, started out from the US, and there were 62 universities initially involved. So now the number is huge, and with the COVID situation, a lot of the education moved online. So these newer sites came in, and they become very popular now. But again, Coursera is still one of the largest provider across the world. And way back in 2012, when things were still not there and the COVID, nobody thought will come and stuff. So that will have to be forced to be, everybody has to be online. Even at that time, they got the best startup award in 2012. So now I'll talk about some of the companies that our students started. So this was through the support of DST. So we way back in 2014, we got this project on DST, running in Innovation and Entrepreneurship Development Center, so IDC. Now it's called by new IDC. Now even the funding has also increased, considering from the one that we got. So here, but even that small funding that we received for 5 years, that really helped us create a cell, uh, have a feature, and then we had a few students who started off. So this is just a short list. There's more students who have started their own companies as well. So the first one that comes to mind is Chota Hospital. They are now called by the name Doc Vita. They started off from this second, third year in their doing BTech in computer science. They could have landed job anywhere, but they decided to have their own. So they tested their idea. So we supported them through this IDC funding. Their focus was to develop a system for doctors, for connecting doctors with the patients, again online through virtual means. And their focus was on the diabetic market. So most looking at this diabetic uh, uh, solutions for them. So and then they ventured into different things as well. They ventured into appointment systems. So the idea was that the patient need not visit, especially in the urban areas and cities and all. It may take an hour to travel to see the doctor. Then there's a waiting time, and then afterwards we have other formalities and things to do for maybe just 10 minutes appointment, or 5 minutes appointment. So the idea was, yes, you can connect them, so the patient can go back, and also doctors may not know exactly what is going on, in last month, what happens from the last meeting to this meeting. So the patient can, from their home, they can do their own, let's say, sugar reading and their lifestyle thing. They can put it onto the system, and when the patient visits, then the doctors can prescribe things based on their history. Right? Uh, so this was the idea of Chota Hospital. Now they are known by the name Doc Vitas. Is now expanded, and they were in Indore for quite a few years, and recently moved to Bangalore. Uh, then the other one is Swaha Waste Management. Um, so this was again a company by our students, started around when they were in third year or so, from mechanical engineering, and others, I think, yeah, two were from mechanical engineering. Um, so they started it on. They made this vehicle, and a small vehicle where they put their own recycling, designed their own system. So they designed their own recycling machine, put it onto their vehicle, and that vehicle would go to the site to recycle. And they were very, instrumental in, let's say, like Indore getting the, clean city thing. And there was a lot of events that happened. So they'll go to the event and do waste management in their events. They got an accolade from various events, as well, large events, and they were serving, in IIT Indore. They get a contract from IIM Indore and other places as well. They are now a big name as well. Um, Third one is Smartify. They started off with, again, computer science students, second, third year ones. They started off with their own um, um, localization based solution, where they got the beacons, and from the beacons they can put the beacons there. So they first, let's say, so the idea was, if you're visiting a exhibition or you're visiting a place, their first like contract came from Indore Zoo. So they will put their beacons there, and with their app, you can, if you, as soon as you get closer to the beacon, it will give you details about that particular animal, which is, just behind. So it's very interactive, and localized based things. So same thing could be applied to exhibition centers. Now, okay, last 2 years nothing much is going on, but otherwise it was designed that yes, you can put in these convention centers and places where people will, be displaying their products, or you will say education fair kind of thing. So where you can get all the information, getting closer to that venue, or that stall. They also started their own, another one, on, I think it was JEE preparation, quizzes and all. So that is also going good. So they were also based in Indore until recently. So last 2 3 years back, 2 years back, I think they moved to NCR region towards Noida. There was another student who worked with us. He created two apps. One of them became very famous. It was a productivity app. So you can check, how much time you have been not concentrating on what you are, supposed to do, and that will give you a feedback, positive feedback, that yes, you are doing. So you can, improve your productivity, or by using that application, if you're, let's say, studying. So mostly it was started off as, spinning off to our students for how much, study time they are doing. So they would install themselves and look at it. So it was a very, popular app until, I think, yeah, 2 years back again. They were more than 500,000 downloads already. So it was, someone who started off his own, a single, person who started from based on in Indore itself, and the business was going. Bought a place. He got a place as well, and where he would, so his office space and all. So it was good to see, that these students who could get placed anywhere, they would have tried, but they still chose to start their company. The good part was they started when they were students. Um, so, there is, you don't have to look for a place, outside to start from your hostel room. You don't, you have a backup from your, parents or guardians about your fees and food and things are taken care of. And then you are into an ecosystem where you can exploit different ideas and explore different things. And even if it fails after 2 years, you know what you want to do. You want to continue on that, or move forward. That is also okay. But you learn a lot of things while doing your own. And part of it we are seeing in corporate world as well. So companies like Infosys, Wipro, and all, they started a program. They have a program called, uh, I think they call it Entrepreneur. So within the company, you are an employee there. You can, let's say, suggest that yes, you want to work on a startup idea, and they will support you. So you can work from the office itself. They give you a sabbatical for a year or something. You can work in the office and then work on your own idea. And if, let's say, the business makes sense or something, they can put in their own resources for marketing and other things as you need. So uh, this is another few initiatives that we have seen in the last few years come up. So I'll discuss more on the government schemes that we have. That some of them have been involved in uh,
So
different things.
if you've changed your screen, it is still on the okay, it's come back. Sorry.
Yes, I'm on the government scheme. So the first one, the one that we see a lot these days. So on 16 January 2016, Startup India scheme was launched um, out from Vigyan Bhavan in New Delhi, and since then it is going good. A lot of startups have come. So India is now, I think, third or fourth in the number of startups registered. It is after US, Israel, UK, and I think in maybe China, and so it is in the first top to three, four numbers. Um, so there is a lot of things. Then there is then through this scheme, there were a lot of other schemes that were proposed. So we saw a tax break that came in. The definition of a startup, like how many years you have to be there and how much, um, you know, um, how many years you have to be as a, from registered company to you can be classified as a startup. So once you classified as a startup, then you can get the tax benefits for how many years on your income from the startup. So I mean, and then once you are registered, then there are different schemes which you could apply to for various funding. Uh, Separate schemes for as a selling your product, and also once as a startup you get this certification, then you can approach different banks and different societies and different government agencies for support in various forms. Then there is we have seen a lot of news about Atmanirbhar Bharat program that started. So it was developing indigenous technologies. Um, so this is something which is needed. I mean, we see a lot of dependence on um, imports on electronic items and other things which we could do here as well. So either it's make in India or even assembled in India is still good because uh, we are still providing these things uh, at a lower cost, and we're not paying it to another country for doing it. So right, so we save on out of this foreign exchange and all, and it's good for our own economy overall. So there are certain schemes that have come up that helps indigenous development of certain. So we're now seeing different targeted ones. So and similar thing we're seeing in defense as well. There's different scheme for naval, army, and also navy has been one of the first one and active ones in this area. So they started their own um, uh, scheme where if you have they can propose solutions, or you can propose a solution and you can apply for some funding through that scheme, so that the equipment and technology is developed in house. We are seeing uh, so other schemes as well. I will probably see something for EV as well, hopefully coming in, so that it can help in telecom as well. We are seeing some softs being given so that the development can start. And recently, just last week or so, there was this big announcement of um, opening fabs in India so that semiconductor devices can be built here. So currently, we don't have a single fabrication facility in the country. We get it from get high-end chips from outside. So this has been in talks for many years, actually 7, 8, 10 years or so. But now probably it's the time that we look forward to it. It is a big project. It's a big project, so we it takes a lot of time and planning as well. But it is useful in future because currently we getting chips from China or Taiwan. They are one of the largest producers. And recently with the COVID, there has been an issue with the chip supply. So a lot of electronic items are not available or very expensive, and it just hit overall. So we also got hit whenever it's R&D because we couldn't get some sensors and stuff. So it's not about the mobility of people, but it was more about the shortage that has happened in this in the production line. Similar thing have impacted our car industry as well. So India produces a lot of cars. We are exporting cars. Um, and we are one of the largest exporters of two wheelers in the Africa region. We are the largest one. Hero is there. There were competition from other places, other players, Chinese and other things as well. But they have kept their quality and their network, so they have become the largest one and good quality product. Um so I mean, so these things are happening and they are going out as well. So we are selling these equipment and machinery outside of the country too. Then Digital India scheme. This started. I think this was one of the first one, even before the Startup India. Now here, the focus was to link up gram panchayats and everyone almost to be linked to the information highway. So for that, we needed connectivity, improved connectivity in all the sections of the country, all the places in the country, and we are seeing some rewards as well now, especially you see during the COVID era, all the education and everything went online, but still we had majority of our people getting connected through. Now it may not be 4G, it may be 3G, maybe even 2G, but still there was connectivity. So some solutions were there. Um, with Digital India, a lot of other things have happened. The UID, the Aadhaar card thing is now there. Also, handled by MIT, um the Ministry of Electronics and Information Technology. Um, Other services, now we are looking at DigiLocker kind of services provided by government. So where again you can upload your see your ID cards and Aadhaar card and other things, and driving licenses and vehicle registrations, and also and that's a government scheme, so you can go online and show it to anyone. It is from the government portal. Uh, so Digital India as was more about connectivity. So once connectivity is done, then we can always look for Atmanirbhar Bharat towards indigenizing our product, and that will help in the coming up of new startups. Now, government schemes specifically designed for startups, we'll look at them now. We have the first one is IIDC, so Innovation and Entrepreneurship Development Center. That is one thing we got as well. Now there's a new IIDC. That is a very small scheme. So in your own college or education institute, you can apply for this scheme. So since you get this scheme, then you run it for 5 years. Every year there will be an assessment on the type of projects that you have supported through this scheme, and there'll be evaluation every year on this. Then there is a scheme called TBI, Technology Business Incubator, which is next to the IDC. That is a bigger scheme uh, where a proper incubation center could be established. It's again a 5 year scheme, uh, but the idea is that you can get an incubator within your education or other institutes. Mostly it is in education institute, but in some startup villages as well, it is there. Uh, and so like IEDC was a very small fund. I mean, when we were doing it 5 6 years back, we would actually get a fund of 1 lakh, I think, per student project, which includes everything from their travel to marketing to whatever they want to do in that. Now I think it is increased to 2 lakh or something. With TBI, I think the overall cost was around project was around 10 crores for the full 5 year scheme, which will involve setting up centers, having some equipments, having a staff, and things for 5 years, and eventually becoming independent. So those things were there. I think now I don't know what is the current figures, but these are the ones. Then DST had different training programs. Um, so I think Dubeji has been involved. I've been involved as well on many of those schemes. Um, I mean, there are a lot of programs going on. There are still currently 5 or 6 programs within Madhya Pradesh that are going on. So every state they will having some programs going on sponsored by DST on promoting entrepreneurship, and they are very good. They're very focused. We've seen. So in fact, last week I was in. I think now currently it's going in Jivaji University, where they're looking at women entrepreneurship development. Um, then there are programs on technology-driven uh, entrepreneurship development programs. Then there are programs on uh, seed and aromatic and medicinal plants. So they're very focused and specialized programs. Some are generic, some are very focused and specialized. They get bankers and some seasoned entrepreneurs to share their experience. I've seen one on dairy as well. Yeah, this one on dairy as well. So a lot of these things are going on, and the good part is with online you can link from anywhere. But I think physically it would not have just been possible to do. So let's make most of it. So this was this. So there are a lot of programs sponsored by DST. So they have a separate stream altogether to promote entrepreneurship. So DST also has a scheme called EIR, Entrepreneur in Residence. So this is a scheme which you can do through certain incubators, where the usual question is once let's say doing graduation. So they developed a product, okay. Then what do you do after you graduate? So who will support you after that, financially, technically, and all? Then there's this scheme called EIR, where it was a generous funding. I think 50,000 per month or something, like a fellowship, and plus you can work in that incubator for a couple of years. So so that there is a support just after your product or project has finished. So after your education, you can go into EIR. Uh, then there are various incubation centers. So various institutes they have their own incubation center. Here at IIT, we have a incubation center as well. Um, then there are so like TBI Technology Business Incubators also an incubation center. So these are I'm now seeing nowadays seeing in many in most education institutes universities they are having their own incubation centers. Some are specific ones. For example, incubation center from DST, they will be they might be theme based, like we see from DBT, Department of Biotechnology. So they are very active. They have their schemes. They keep on advertising in various newspapers. They have different schemes called BIRAC and all. So they have their own incubators, but their focus mostly is into the biology or medicinal related things. Um, Similarly, Ministry of Education has got into this as well. They started a program called Imprint, which ran for a couple of years, which was um, partial support. So let us say you are a company, and let's say you have to develop a product or do some R&D, not able to put in all the funds. So here, uh, Ministry of Education will chip in. So this through this program, it, I think there were two different streams. One was like 50-50%, other one was 25-75%. So the startup or a company puts 25% in cash, and the rest comes from the government for execution of that project with the education institute and the private player. Then a Spark program. So this is also almost coming to an end now, which encouraged or supported actually faculty members from outside and Indian students to travel abroad for a couple of months. Um, so we'll get experts from global experts. They'll be giving talks. They'll be interacting with the students, startups, and all, so that they can share their experiences uh, and technology. Then there is TIH, Technology Innovation Hub. This is our latest thing. There are a lot of TIH has been set up in various institutes. So at Indore, we have got one as well on simulation and modeling, software simulation and modeling. So there are different ones. They're also theme-based. So like there's one in Triple IT Bangalore on future communication, so mostly 5G and beyond communication systems. Then we have IoT, which is handled by IIT Bombay, Tehan. So they are supporting both student fellowships. They're also supporting startups to come up. So they have different programs within their own TIH, and each TIH is sort of independent of handling these tasks. Then there is other schemes as well. When we saw Niti Aayog, the erstwhile planning commission, they have come up with their own schemes too. They have this ATAL incubation centers, um, which are in both government and private organizations. I think overall support is I think 10 crores for 5 years project, where they can also give some seed funding and give a again a uh, uh, a ecosystem where you can go and incubate your companies. They run their own competitions in order to attract different ideas. So and then one thing I did not mention here, it is not in the slides, but there are similar schemes from MSME as well, Ministry of MSME, so medium and small scale enterprise. They also start these centers with education institutes. They'll put their centers there or support various projects which are running in an education institute through this, and they provide certain funding for these projects. So there is also there's a lot of scope and things available, but you have to reach out to them if you're not. You can check with your institute. They will probably have a entrepreneurship cell, and there might be incubation center as well. You may not know, but they might be already there. So there's a lot of just things in the ecosystem that can be exploited, and the government schemes are there. So let's now talk a little bit about technology. So you can see my slide on IoT introduction fundamentals.
Yes, sir. It's visible.
Okay, perfect. Thank you. Okay, so let us see what is the term. So IoT is a topic that I chose because it is more generic. Um, we all can relate to. We all are using it already, and since a lot of speakers are from different background, from science, engineering, and pharmacy, and others of faculty, student, staff. So we can sort of relate with this. We are now uh, seeing this in also non-tech areas as well. So nowadays, when you watch a promotion video for a air conditioner, or washing machine, or something, they would say that's IoT enabled, right? Or IoT device. So, what is IoT? Let us see, and how it is coming to us. So, we'll not go into the exact technological details, but this is something because you see nowadays, if you are trying to do something, startup technology is something that you have to rely on. From basic things like making payments to product delivery, you have to rely on uh, these technological solutions, which will make it more efficient as well, and faster, and you can scale your businesses. So here I'll cover IoT, but similarly, in a similar vein, if let's say you are into a business where you feel that there is some kind of analytics required, so you may look at exploring machine learning and all for your needs. Um, So we are seeing that also coming to a lot of business problems, and there are different new technologies like blockchain. They're also coming. That's mostly for the technology people, um, but they are coming. So based on that technology, different businesses can be formed, similar to, let's say, Airbnb and others. They could be formed. So we need to be aware of this. So even, let's say, you're so I was talking to someone who are getting into this real estate business. They're also looking at machine learning or some kind of algorithm based searching, so that they can target specific customers with their needs. And also there's a lot of these analytics and things are going on, um, which I think as a small startup to a big company, you cannot ignore this thing. And ICT is something that we have to live with now. From basic things, from invoicing to reconciling your accounts. So everything is now online, using WhatsApp or internet or something. So you really can't live without it. Um, so Internet of Things is another something similar that can be applied to any industry, and it is already actually being applied to any industry. So I thought I'll give you a certain idea what it is, because we hear about um, other things. So IoT refers to a system of interrelated, internet connected objects that are able to collect and transfer data over a wireless network without a human intervention. And that is what is becoming popular now. Um, so IoT, as a definition, if you look at it, it's interrelated system. So it is not only one system; it could be multiple of these systems connected together through internet connection, which will collect and transfer data over a wireless network without human intervention. So IoT is a inter-networking of physical devices, vehicles, buildings, and other items embedded with electronics, software. You have different sensors. That is important for an IoT setup. So, some kind of sensors there, either a motion sensor or a pollution sensors or temperature sensors, humidity sensors, some kind of sensors. There's some actuators which is going to work on that thing. So something like automatic braking systems or automatic controller of switching on and off of air conditioners. And of course, they're all connected to a network connectivity that enable these objects to collect and exchange data. Now, ITU definition is the IoT can be viewed as a global infrastructure for the information society. So this is enabling advanced services by interconnecting physical and virtual things uh, based on the existing and evolving interop. So ITU, ITU is International Telecom Union. So they set up different standards like we see 3G, 4G, 5G. Their focus is on telecoms. Um, Similar to IEEE one that we see on our Wi-Fi modems and our handsets. Also, it is written IEEE this standard. So what does that mean? That this device is compatible to that particular standard. So I can purchase another device from anywhere, any manufacturer, but as long as it has the same protocol, it will work. So similar standardization we see in our electric socket as well. So we expect it to be all 220 volt, 50 hertz in India, and there will all be this roundy uh, type of sockets which will fit into this thing. So they're all standardized under the Bharat standards and others. So they're all in standardization. So IoT is like a United Nations of telecommunication people. You can say it has academics, politicians. So government, not politicians, but the government, representatives, then big telecom operators and product manufacturers, the Samsung, Huawei, and all, they come together to form certain standards. So they saw that there is a big revolution happening. So they gave their own definition, but they kept it open. Yeah, if you look at this says things based on existing and evolving interrupt. So it did not say that IoT is there for 3G, 4G, 5G, 6G, 7G, or IEEE standards. It says it is evolving because this technology is evolving and evolving very fast. So things are uh, changing in this arena quite quickly. But uh, as long as it's a part of that global infrastructure of information technology, we are living in information society. As long as it is part of the same global um, framework, uh, and providing advanced services for physical and virtual systems. Okay, so now let us see what is the fundamental characteristics. So I'm on this slide which says fundamental characteristics of an IoT system. One thing you said is interconnectivity. Now, with regards to the IoT, anything can be interconnected with the global ICT infrastructure. Uh, Heterogeneity as well, so interconnected, that they all have to be connected through ICT. Then heterogeneity, the devices in the IoT are heterogeneous as they're based on different hardware platforms. So we see that, right? We're using different types of phones. Uh, it could be Android, it could be Windows, it could be iPhone, so that are working on different platforms, different processors are being used, different hardwares are there, uh, and different networks as well. So it could be Wi-Fi or cellular network or Bluetooth. Uh, um so they all need to be interconnected. Now they interact with each other devices through different platforms. So there are different protocols that are there, which will help. So we'll see how it is achieved. But these are the fundamental characteristics of an IoT setup. We have interconnectivity, we have heterogeneity. Then the next one is dynamic change. Uh, so the state of a device changes dynamically. Example, sleeping or waking up, connected or disconnected, as well as context of device, including location and speed, they may change. So you might have a sensor on a vehicle. So this vehicle, if you look at example of autonomous vehicle, so this vehicle is continuously moving. So state is always changing. It may go through a tunnel or it may go through a flyover. The signal may change. The speed and location is changing continuously. Um, so there might be a setup where you have different sensors for, let's say, deployed in the field or in some plant, chemical plant or somewhere, wherever. Let's say you're sensing something. Let's say you're trying to sense a temperature. So for temperature sensing, you outside ambient one, you may need to sense it maybe once in an hour, so that the this can go into sleep mode. The sensor can go into sleep mode and have to wake up after an hour. It saves energy and also reduces RF interference. Then it can collect the information and send it across. Uh, so it can sleep and wake up. It's connected or disconnected state, I've already said. So it could be, let's say, going through a tunnel, that could be disconnected, it could be connected. So it has to be adaptable to dynamic changes. So moreover, the number of devices can change. And so that is something that we will see here, because that's what is happening over the uh, last decade or so. That number of devices have increased tremendously. Now, this enormous scale. So the number of devices that needs to be managed and that communicate with each other will be at least an order of magnitude larger than the devices connected to the current internet. So it has to be scalable. So today, if I'm saying, let's say 100 devices, so it could be, you see, if we go forward, could be 200 next month, next week. So this is a continuous process, and through with in a way forced by the COVID situation, a lot of the automation has happened in many places. Um, so that automation requires IoT setup. Um, so the scale is really huge. The ratio of communication now triggered by devices as compared to the humans is already much larger. I have one slide here. Yeah, this is the one. So if you look at this, on the x-axis I got years, and on the y-axis we see the population, the connected devices, and their ratio. So way back in 2003, just in 2 decades, um, we had about 500 million devices, and the global population was 6.3 billion. Around 2008, 2007 time, we were about the same number of connected devices than the human beings. Moving forward to 2010, we have a global population 6.8 billion and connected devices being 12.5 billion. So this was approximately 1.84 or close to two times the number of devices than the human population. 2015, we see this ratio go up to 3.47, where the global population world population was 7.2 billion, whereas the connected devices 25 billion. Even further, 2020, we see 50 billion devices and global population of 7.6 billion. So a factor of 6.4, so close to we're now ending 2020. So it should be around seven times more number of devices than the human being. So uh, I mean the scale is huge. We need to handle them. That so the scale is huge. That means it is coming to our daily life. So all we're all linked to this network already. We're already part of this IoT setup. So some of us are using smartwatches already. So it has multiple sensors, uh, and many of us have two phones. Some of us have got a phone, a laptop, and another phone. So three or four electronic devices we carry every day. Uh, then our no, fridges, washing machine, they're all getting smart with different sensors and things. So IoT is something which is there. So in chemical process plants, uh, in mining, in other places, logistics, it is already there. But let's look at a short, go a little bit in the history and see that this term IoT is actually not a um, it's not a very old term, but still it was started even longer. But the actual idea for connecting devices has been there in 1970s. But the term IoT is about the late 1990s, where back then um, this is called as embedded internet or pervasive computing. So pervasive computing was really a buzzword. So as now the buzzword, we hear about machine learning, AI. Way back in 1999, embedded internet was actually a buzzword at that time, and pervasive computing was coming up. Um, and that was just e-commerce bubble that was being built around that time. So Kevin Ashton actually coined the term Internet of Things. So Kevin Ashton used to work for Procter and Gamble. So P&G, as you know, is a cosmetic products and baby products and all that they produce. So Ashton, who was working in supply chain optimization, he was looking at solution based on RFIDs. At that time, internet was really as very hot technology around 1999. Everybody was talking about it, and because of it, somehow he called in his presentation the word Internet of Things. Now, even though Kevin grabbed the interest of some P&G executives, the term Internet of Things did not become a widespread till for the next 10 years. So around 2010, this term became famous. Before that, we used to call it by wireless sensor network, WSN. But if let's say Kevin was working for Google or Microsoft or someone, then technology company, then this term might have been a hit even 10 years prior to that. But since I'm working for P&G, the main focus was not into technology business, but there's a short history of the term. Now, again, deploying an IoT setup. Let's say you are planning to set up a small manufacturing unit or even let's say a sales counter or something where you want to, let's say, track your product like uh, so you need to do a IoT implementation. It's not easy to do, but once it is done, so a lot of these things can be automized. Your inventory management, even we have people working on so trying, if you have, let's say, manufacturing facility, so they will tell you with some analytics, it can tell you that yes, this component in your big machinery might fail, or what is the likelihood of it getting failed in next 1 month or 15 days. So you can build up your inventory or a request for maintenance or something around that time. So those are things again enabled through IoT. We hear about digital twins also enabled through IoT. So let's say you decide to start your own business or manufacturing things. What are the basic components of an IoT implementation? So first you have different sensors. Then you need to have a network. We work against different standards. Then you have intelligent analysis and intelligent actions. Uh, Now, IEEE is the largest body. So when we see IEEE, three times C, so it's called IEEE. IEEE is the largest body of electrical, computer science engineers across the world. So most of us are member of IEEE. So IEEE also saw this change was happening, and IEEE, otherwise, from the name that you see in the specification for your Wi-Fi modem or your phone when you look at wireless LAN connection. So they are a big publishing house. They moved into standardization as well a few years back, and this is the most popular one. They also came up with WiMAX, but again in the large area they were not very successful, so that didn't click. So we had 4G, 3G, and 4G to counter that. So now let's look into this. So IEEE has come up with its own definition of what is a sensor. Now, a sensor is an electronic device that produces electrical, optical, or digitally derived from a physical condition or an event. Let's say you have a small weighing machine. So weighing machine is also converting it from a physical thing. So it's a cyber physical system. So from a physical measurement, it is giving you it in electronic form, right? Similarly, we have these thermometers, what we use at our home as well. So it's measuring the temperature, which is a physical quantity, and converting into electrical form or electronic form. It is then showing you the reading. Right? So that is what a sensor does. It takes some measurement in the physical world and produces in electrical, optical, or digital drive data. Mostly it is electrical, mostly it's electronic data. Now, data produced from sensors is electronically transformed by another device into information that is then used for making decision by the intelligent devices of the individual. So let's look at what are different type of sensors. So we have temperature, motion, biological. So purpose could be a different. So it could be for temperature, thermometer, gyro or other type of sensors. Then how accurate they are again depends on your application. You might let's say you're putting them in an airplane, it has to be very very accurate and very reliable. Whereas let's say if it's a let's say a reverse sensor in our cars, so that may not be very accurate to let's say a few millimeters. It doesn't need to be. Centimeters are also okay, and also if it fails, we can always get a new one. It's easier to be replaced. So on your application, these will depend. And let's say if it's in a refinery or a chemical plant, huge, very high temperatures. So a different type of sensors and reliability needs to be assessed. Again, same thing goes for range and resolution as well. The level of intelligence. So dealing with noise and interference is another thing which we are seeing now. So when let's say you purchase a new phone, are clicking pictures, photos from it, and then after a few months, the camera's lens they get scratched, but still you get good quality because these sensors are now able to deal with the noise and interference by themselves. And another advantage is that over the years, the cost of these sensors are coming cheaper and smart. They're making smarter and smaller. Once the sensors are there, then you have to collect the information. That this information has to be shared across the network. So for that, we can use LAN, MAN, WAN. We are already using Wi-Fi, Bluetooth, low power Wi-Fi. There's another technique called LoRa, and then LTE is our 4G networks. Then recent promising is Li-Fi, which we touched base on visible light communication. And these are some of the data rates that we've seen how it has changed over the years. But the good part is from the 5G, after later 4G standards onwards, people started to look at this alternative because IoT devices mostly like it's a sensor type of network where a lot of these small sensors would be there. They will send some all information intermittently. So the driving force for widespread network adoption in IoT is high data rate, low pricing, virtualization. Now we are seeing anything as a platform, as a service, infrastructure. We are using software as a service, right? The Google Meet we are using at the moment, and IPv6 deployment. From technological point of view, IPv6 was very important. Otherwise, you could not suffice the type number, the billions of addresses we needed to connect to devices. So this we have seen. We are using it now. Quite often in the COVID era to run our businesses and work going. So Google Workspace, Dropbox, GoToMeeting, and a lot others. Now these are certain challenges. Yeah, this enormous growth in connected devices, availability of network coverage could be an issue. Security is something that needs to be looked at as well. Because we're doing a lot of our financial and other transaction now, so onto the phone. So secure, and if you have let's say a network or different sensors in IoT setup for your farm or a dairy business or something, so you need high security as well. Somebody can maybe tamper with it, and some wrong action might happen because of this tampering. Then power consumption also could need to be low. Uh, then the third stage, which links the sensors and the network, is the standards. So we have these different standards I said about the communication part. Uh, Similarly, there are so things like Wi-Fi, HTTP, Bluetooth, ATL. So they're all different protocols. So in standard, there are two things. One is the regulatory standard, and then there is a regulatory bodies are there. So for example, HIPAA in the US. So India, we for telecom we have TRAI. For electrical equipment, mostly it's the BIS standard, Bharat standard, BS standard. So then there are different agencies which look into the compliance from different product vendors. So there is a regulatory framework there, and different other things are more I'll say different from ICT world. We because there's not much standardization there, but still we have these things like SQL and NoSQL for storing our database and also those. And then now there are talks about including these regulatory things, standardization and things within the um, within because they're mostly gray areas. Different agencies will do it differently, and some places, especially like things like privacy and all, there's no not much there in the standardization world. So there is a discussion, and possibly in the 6G era onwards, that will have a standard on the privacy as well. But with standards are there, so it's easy for us to interoperate. Because I know, let us say I've collected some information sent by one sensor over Bluetooth. So smartwatch, which detected blood sugar or BP level, it's sent through Bluetooth to my handset. Now from handset, I can send through Wi-Fi or cellular network. So they all are interoperable because they are again standard. So my device, my handset knows, okay, I've got the data from a Bluetooth device. How I need to decipher remove all the protocol things, get the data out, and that data can then be put onto the Wi-Fi one and then move forward. Um, so that's because the standards are there. So anybody can implement. You can also implement this protocol and and start decoding. Now, intelligent analysis is the next stage, where so we know the fourth pillar of this. So this is where you've collected the data from various standards, various networks. Now we want to do some analytics on it. So you would actually be having things like computer vision, natural language processing, speech recognition, and other type of systems to do analytics on the collected data. A lot of this data nowadays is also crowdsourced, but basically somebody has to do analytics. So you run the AI engines or ML engines, which will um, learn and then do action on it. Um, so now we actually move on to the last part of this. So fifth stage is the intelligent action. So once, let's say, the data is collected, once the analytical information, important information is taken out, then we run it through a okay, visualization we could do from UI and UX. That is okay. Then we have to do some kind of an action. So, for example, let us say you need a braking system. Like you have an autonomous vehicle which is working on its own. It's collecting data. It sense that okay, there is some person is trying to get in front of the car or vehicle or on the side, which but it is very close that it can cause an accident. Then an action has to be taken automatically by the machine. So in that case, an actuator is required. So this actuator is going to be putting the brakes. So these are some of the things. So for example, let's say you have a farm. So in a smart or precision farming, you have put this different sensors. They sense, okay, the water level is very low. We need to start. So let's say the sprinklers might start automatically. A similar thing for you have machine setup. This one machine gets an error or some fire happens in one of the machines. So then the production line, the one in the front and one afterwards, can be told to stop. So these corrective actions can be taken by uh, by the actuators. So some of the challenges here as well in intelligent action is machines actions are is in an unpredictable situation. So how will it happen in unpredictable situation? So that is something we need to be careful of. So for example, you're having an autonomous vehicle and there is some road work or something has happened or suddenly so what kind of divergence it has to take. So it cannot be blindly following the same route which has been there or the system is telling. So it has to be a real time thing on the real physical world. Then information security and privacy, that's another big issue, right, that I told you about. And machine interoperability. So if you had, let's say, two different machines from two different vendors, how will they operate? Again, mean reverting human behavior, slow adaptation technology. That's another thing. But slowly, things are moving in this direction. So, my so last slide that I will go today is that IoT is an ecosystem of ever increasing complexity. It is a new wave of innovation that will uh, humanize every object in our life, which is the next level of automation of our things. So, for example, I said, you will have sensors into your fridge, which can tell you if you're running short of milk. It can even order the milk for you, or it can tell you in your app that of milk is finishing. So on the way back from work, you can collect it on the way. So this kind of automation will come in. Or you have a RO device, it's telling, okay, this reading is not correct. So there's probably a time for maintenance or changing of some parts, so that you can do. Um, then convergence of technologies will make IoT implementation much easier, faster, which in turn will improve many aspects of our life at home, at work, and our uh, businesses and startups. So as I said, you in today's world, uh, you will find it hard to run a business without the successful business without technology involvement in it, being from payments, collection, making payments, to stocking things up, to designing, to do analytics, to see what is your customer behavior. So technology needs to be there, and IoT is something that is, we are actually in a way you're using it already. As I some already has smart watches and wearables and things, but more will come as you look at this autonomous vehicle, autonomously moving vehicles and logistics and other industries. So we'll see this more coming in the future. So what I can do is firstly is pause here. So any questions and things we can discuss. Anything anyone wants to, or they can unmute or write in the chat box. Yeah, and any questions, queries, anybody wants to discuss?
Participants, we had a very impressive lecture from Professor Vimal Bhatia. He gave the technology aspect as well as the aspects of entrepreneurship and startup, because he himself has guided many projects, many startups. So you may discuss over here your ideas, or maybe you are thinking of any commercialization project in your institute with your students or of your own. So I think we have a very experienced faculty with us. You can please go ahead and ask questions or discuss any situations which you are having in your institute. Please go ahead.
Good afternoon, sir.
Good afternoon. Yes,
Hi,
can
sir.
you hear me?
Myself, Amit Naik, sir. First of all, thanks for this wonderful lecture, sir. Sir, in your this PPT in intelligent analysis part, you have taken the example of Bluetooth communication, sir.
Okay.
So I have just a simple question. Is it possible to transmit from Bluetooth and receive from some other device, sir?
So okay, what there I meant was that this interoperability is there.
Yes, yes.
Uh,
Is it
so you
possible,
are
sir, nowadays?
so now basically let's say you're connected from the Bluetooth device,
Yeah.
and it is now so like okay. So now we can take an example of so I took an example of a smartwatch. So you have a smartwatch which is
Yes,
measuring
yes.
your let's say BP levels or something, or how many steps you have walked, and that information gets transmitted to their app into your phone through a Bluetooth connection.
Yes. Okay, sir.
Now, once that information is there, then that information you send it through a Wi-Fi or cellular network to, let us say, a central store. So a Bluetooth device will hear or listen from a Bluetooth device only, but within a device you can move from one protocol to another. So you can carry that information one protocol to another.
Sir, is it possible to transmit from Bluetooth and receive from Wi-Fi
So
or some
even for
other?
example, let's say somebody is listening to music from or video from online
Yeah.
sources. So you can connect to the YouTube, which is through your cellular network or Wi-Fi network. Sorry, I have to switch on the charger, so you might get
Yeah,
some
yeah,
noise.
yeah.
So yeah, that you can do, and then you're listening it on your Bluetooth headset.
Okay. Sir, what the main problem I am seeing in communication field is that we are at the we all maximum are at the user end, sir, and at the production or development end we are completely dependent for other countries for hardware. So that's why not so much jobs are generated in India for that IoT or like that. As technology is growing exponentially, but jobs are not there. So, what are your suggestions for students for startups in this field, in IoT or in wireless communications? Hello,
Yeah, so
yes.
this is yeah. So you are
Am I
right
audible,
that
sir? Yes. Am I audible?
yes, yes, yes,
Yeah, yeah.
yes,
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 yes, yes. Yes.
yes, yes. So you are right that we don't have many um, equipment manufacturers
Yeah, yeah.
uh, here, and that is but yeah. So what we have been doing. So we had, companies like CDOT and others doing it, but again, not a very large scale. And then we have the Sankhya Labs, Mimo, uh, one based out of Bangalore and Hyderabad. So a few companies in the southern part of the country where they have in here also in the Delhi NCR region. Also, I've seen some companies using SDR, software defined radio. So they are building their own SDRs
Yes.
and they are exporting to
Okay.
rest of the world. Africa and
Okay.
others
Yes.
is going. They're in the business for last 15-20 years. It's not
Yes.
anything new. So it is happening. Is it not at that scale? But other things are that yes, they can do.
Mm.
A lot of the IT industries are set up here. So we see Qualcomm, and other companies like TCS, Infosys, and all. They're also developing things here, and there has been recent push through this Atmanirbhar Bharat thing, and I think Jio has invested a lot to, and TCS are also now trying to build their own 5G system. Um so we have, you know, um this government-supported project, a big project from IIT Madras was coordinating it, about 200 crores one for different older IITs and all. Where we were developing a full prototype end-to-end system for 5G. So that ecosystem can be tapped in, and I'm seeing new companies coming into this arena as well. Um, so things are opening up,
Yeah.
maybe a bit slowly, but a lot of then, work that we do comes into the services part. We do a lot of in India. We do a lot of uh, development of these telecom standards. We have been doing it.
Yes, sir.
Okay, they are multinationals, but they're all based out in India, and we are developing them. So Ericsson, Nokia,
Yes.
they all have centers here.
Mm.
So we have Hughes, Recent. So in the Delhi NCR region and Bangalore region, and now even in Pune region, there are a lot of telecom companies. But mostly we are doing it on the, yeah. So I agree. Mostly it is on the software side, mostly on the software, on the embedded uh, software side, than the equipment itself. But I hope it is going to change. With the Geo and some other players coming in and doing some indigenous development here.
Yes, sir. Sir, in your PPT, you have shown the data from Cisco for showing the number of users, increasing predictable number of users per after some years into 2030 or something. That number of users are growing or number of devices are
Yeah, number devices.
yeah.
Yes, yes, yes.
Any website is there for data set for analysis like for data traffic or for call drop or number of users or devices like that. For example, for medical field, they have sufficient data sets for the
Yes,
analysis purpose. But
yes,
for
yes.
telecom engineers, I have not seen any authenticated data set for example, call drop. We are all facing call drops nowadays frequently. So any website is there for data set for analysis of communication engineers, sir?
No, actually, I've also not come across
Yeah.
this. I'm also not come. So we also struggled when we were doing work on caching and all.
Yes,
We
sir.
needed
Yes.
some information, but
Yes.
we couldn't get hold of it.
Yes.
So what we do instead in communication is we look at these statistical models.
Okay, sir.
So if somebody is we are saying traffic is there, so network traffic will say Poisson distributed or something.
Yes.
So those things you'll see in the research papers as well.
Okay.
So mostly there'll be some kind of a distribution or some statistical model will be there,
Yes.
and some parameters will be given. So those we can use.
Yes.
But yeah, you're right. I mean, I don't know. Maybe TRAI publishes it now. I don't know if
It
they are
publishes, but
publishing.
it's not published the data about that call drop and traffic and that personal data which that websites have. It only publishes the number of
Okay.
users per cities or that's it, sir. And
Okay.
yeah,
Okay. Okay. Okay.
uh,
Okay.
uh,
Yeah, no, call drop is a
yeah,
big issue, but then again,
yes,
the providers will not provide that
yeah,
information.
yeah.
Yeah, so it's hard to get that. Yeah, yeah, yeah. I've also not. Sorry, I've also not come across this information.
Thanks a lot, sir, for this wonderful session and for this information. Sir, some questions I will mail you, sir. So please reply.
Okay,
Yeah.
sure, 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 sure,
Thanks a lot,
sure.
sir. Thank
So
you.
thank you, Amit. Thank you.
Okay, friends. Okay, friends, do we have any more questions, suggestions? from Dr. Vimal. Sir, I think, pardon. Nishanji, you want to speak something?
No, sir, it was a nice session.
Okay, okay, okay. Yes, so, sir, I thank you on behalf of NITR Bhopal and all the participants for such a wonderful session where you give a very good overview of the technological aspects about the what is entrepreneurship and what are various kind of enterprises. So I think it gives a holistic approach, and many of our participants will be able to start these kind of activities in their institutions. Sir, you have been always extending support to us, and I hope in future also we will be getting the same in our future endeavors. Thank you so much for joining today, sir. Bye. Take care.
So thank you very much. Thank you, Nishiji. Thank you to your team for hosting me. It's always a pleasure to be with you. Thank you. Thank you. Bye bye.
Same here, sir. Bye.
Thank you. Bye bye.